Okay, question one. Becky sometimes works in an office and sometimes works at home. The random variable x denotes the number of days that she works at home in any given week. It is given that the probability distribution is that, where k is a constant and x is 1, 2, 3, or 4 only. Draw up a probability distribution table for x, giving the probabilities as numerical fractions. Okay, well, I think let's just get along and do that. I draw up my table here. Okay, so I'll label this as x, and x can be either 1, 2, 3, or 4. And then the probability that x is equal to x, well, if we start with x is equal to 1, we're going to have k times by 1 times by 2, so that's 2k. And then if k is equal to 2, then we're going to get k times by 2 times by 3, so that's going to be 6k. And then if x is 3, we're going to get 3 times by 4, which is 12 times by k. And if x is 4, we get 4 times by 5, which is 20 times by k. Now, hopefully we should know that the sum of all probabilities is equal to 1, right? So if I was to add up all of these probabilities, right, then what I should get is 1. So if I do that, I'm going to get 2k plus 6k plus 12k plus 20k. So 2k plus 6k is 8k, plus 12k is 20k, plus another 20k is 40k. So I get here that 40k is equal to 1, which means that k is equal to 1 upon 40. Okay, and if k is equal to 1 upon 40, then I can just replace all of these k's with 1 upon 40. So I can go back and do that. You should probably repeat the table, by the way. Yeah, why is that not working? Let's try that again. Yeah, there we go. You should probably repeat the table and keep the table with the k's, but I'm going to do this a bit fast. So like that, 2 upon 40, 6 upon 40, 12 upon 40, and 20 upon 40. And that's going to be our probability distribution table. Okay, then part B of this question, we want to find the expectation and variance of x. Now, the formulas for the expectation are we do the summation of each x value times by its corresponding probability. And the variance is the expectation of x squared. So in other words, we do x squared times by its probability, and then minus the expectation of x there, all squared. So if we were to do this with our distribution, the expectation is going to be this guy times by that guy, plus this guy times by that guy, plus this guy times by that guy, and plus this guy times by that guy. So why don't we just get on and do that? So our expectation is going to be equal to 1 times by 2 upon 40, which is 2 upon 40, plus 2 times by 6 upon 40, which is 12 upon 40, plus 3 times by 12 upon 40, which is 36 upon 40, and then 4 times by 20 upon 40, which is 80 upon 40. So if we add up all of those, 2 plus 12 is 14, added on to 36 is 50, added on to 80 is 130. So we get 130 over 40, and that's the same thing as 13 divided by 4. Okay, so 13 upon 4 is our expectation. Well, to get our variance, probably the best thing to do first is to find the expectation of x squared. And so we're going to do all the same thing, but instead of doing x times by its probability, we're going to do x squared. So we're going to do 1 squared times by this, plus 2 squared times by that, plus 3 squared times by that, plus 4 squared times by that. So if we do that, we're going to get 2 upon 40 is our first value. And then we're going to get 2 squared, which is 4, times by 6, which is 24 upon 40. And then we'll have 3 squared, which is 9, times by 12, which is 108 upon 40. And lastly, we'll have 4 squared, which is 16, times by 20, which is 320. So there we get 320 upon 40. Okay, so then if we add up all of these values, I think that gives us 454 upon 40. So 454, that's a funny looking 4. 454 upon 40. And of course, what I said was that the variance of x is equal to the expectation of x squared, so that's 4, 5, 4 upon 40, minus the expectation of x all squared, so 13 upon 4 all squared. And I think if we key that into our calculator, then what we should get is 63 upon 80, and that will be our variance. Okay, then, question 2. The weights of large bags of pasta produced by a company are normally distributed with a mean of 1.5 and a standard deviation of 0.05. We want to find the probability that a randomly chosen large bag of pasta weighs between 1.42 kilograms and 1.52 kilograms. Okay, with all these questions, I think it's always helpful to be defining our random variable and our distribution. So we're going to start with that. We're going to say let x be the weight of a bag of pasta. The weight of bag of pasta. And therefore, we can say that x is normally distributed with a mean of 1.5 and with a standard deviation of 0.05. So we write 0.05 squared there because that's the variance. Now, what are we being asked to find? We're being asked to find the probability that our x value is between 1.42 and 1.52. And I think it's helpful to draw a quick diagram so we understand what this is actually going to look like. So if I was to draw the distribution, then it's going to look something like this. So forgive my slightly bad drawing of a curve there. Okay. So we know that our mean, the center of this distribution, is going to be roughly there. That's 1.5. And we're interested between 1.42 and 1.52. So let's try to draw that on and say 1.42 is here. That's 1.42. Okay, that. And 1.52, let's put it there, 1.52. And so what we're being asked to find is this region here in between those two, right? So that region there. Now, what's that equivalent to? Well, it's equivalent of taking the probability of everything to the left of 1.52. So that whole region there, all of that, okay, minus the probability of everything to the left of 1.42, right? So minus all of that thing there. So we can rewrite this and say that the probability we're actually being asked to find is the probability that x is less than 1.52 minus the probability that x is less than 1.42. Okay, so we've broken down the problem into two separate parts. Okay, so what we're going to do now is I think we just do each one individually. We're going to find the probability that x is less than 1.52. So the probability that x is less than 1.52. And we can convert this into the z distribution by using the formula z is equal to x minus mu upon sigma. So 1.52 is our x value minus the mean, which is 1.5, divided through by our sigma value, which was 0.05, right? So that gives us the equivalent z value on our z distribution. Now, if we do that, we're going to get the probability that z is less than 0.4. Okay? All right, well, we don't have to do any manipulation there because the table of data tells us how to find the probability that we're less than a certain value. The table of data only takes positive values of z, and that's positive, so we're all okay. So we just go across to our table of data, and we find out where 0.4 is. So where is 0.4? Let's just find it there. That is 0.4 there. And we want 0.40, right? We don't want anything else. And that value is 0.6554. Okay, so we're going to write in there 0.6554. All right, then. Well, then we want to find the other probability, the probability that x is less than 1.42. And again, we can convert that, just get rid of that because it looks like an 8, 1.42. And we can convert that to the z distribution, 1.42 minus 1.5, all divided through by 0.05. And if we do that, we're finding the probability that z is less than negative 1.6. Now, that creates a problem And the problem is that the tables that we're given do not take negative values of z. So let's just quickly think about this. I always think it's helpful just to draw a quick diagram. What is the z distribution? The z distribution is the normal distribution that is centered upon 0 and that has a standard deviation and a variance of 1, right? So it looks something like that. Okay, so it's centered upon 0. Now, we want to find the probability that we are less than negative 1.6. So where would that be? Well, let's put negative 1.6 there, negative 1.6. What we've been asked to find is that region there. Well, we can use the property of symmetry, right? And say that if we were to reflect this to get to positive 1.6, that would be equivalent to finding that region there, right? So these two shaded regions, those are the same. So I can rewrite this and say, it's equivalent to being asked to find the probability that z is greater than positive 1.6. Well, again, we come across another trouble because the tables don't give us the probability that we're greater than a certain value. They give us the probability that we are less than a certain value. So if we want to find this region here, what we can say is it is the same thing as 1 minus the probability of this whole region here, right? So in other words, the table of data, what it tells us is it tells us this green thing here, right? All of that region. Can you see that? That's what the table of data tells us. And so the red region here is going to be the same thing as 1 minus all of that green, because the probability underneath the normal curve must be equal to 1. Okay, so we're going to rewrite this as, let me just change that, equivalent to 1 minus the probability that z is less than positive 1.6. So now we're going to go to our table of data. We're going to find 1.6, wherever that is, 1.6. I'll highlight it in blue, I think. So 1.6 is there. We want 1.60, so that's 0.9452. Okay, so we go down here. We're going to write that out. So that is 1 minus 0.9452. And that will give us 0.0548. Okay, so then what was our conclusion? Well, we said that the probability that we're between 1.42 and 1.52 is going to be equal to the probability that we're less than 1.52, right, which was 0.6554, minus the probability that we're less than 1.42, which was 0.0548. Okay, and so if I do that, I get 0.6006. Now, just a quick note, on the mark scheme, what you see is you actually see 0.6001, right? So that 6 there is a 1. However, what they also state in the mark scheme is that that is the correct probability and that is the correct probability, right? So in other words, these values, they say are right and right. So I think what's happened is they've done their subtraction and then the mark scheme, they've made a typo and that digit is wrong. Okay. This guy here, by the way, even if you wrote that and let's say that was the wrong value, quote unquote, the mark scheme actually would still accept it because they accept everything, I think, from 0.6005 to 0.6010. All right, so that would be fine. But I'm very confident that that is right. Okay. Okay, part B of this question. The weights of small bags of pasta produced by the company are normally distributed with mean of 0.75 and standard deviation of sigma, so that's unknown. It is found that 68% of these small bags have weights less than 0.9 kilograms. Find the value of sigma. Okay, well, again, we're going to define our distribution. Let y be the weight of the small bags. So always be in the habit of doing that, even if you think it's completely unnecessary. You want to do it because it protects you from errors in other questions. So y is normally distributed with a mean of 0.75 and a standard deviation of sigma, so sigma squared there. Now, I think a diagram is pretty key. So 68% of these small bags have weights less than 0.9. So let's try to draw on what that is going to look like. So here would be our distribution, like that. So I'll try to draw a nice normal curve, something like that. It's not great, but never mind. Okay, something like that. And our mean was what? 0.75, wasn't it? 0.75. And what we're told is that 68% of the 60% of these small bags are less than 0.9 kilograms. So let's put 0.9 here, 0.9. Okay, and basically what we're being told is that 6% of the data is within that region. Okay, so 0.68. Well, the way to do this is to consider the equivalent value in the Z distribution. So what I'm going to do now is I'm going to draw the Z distribution. The Z distribution is the normal distribution that's centered on 0 and with a standard deviation of 1. Okay, so here we are. Let's just label that. So in other words, this guy is the Y distribution there. This guy is the Z. And what we know is that there is going to be an equivalent value on the Z distribution, which I'll call Z, which also has 68% of the data to the left of it. All right, so what I'm trying to say is, on the Y distribution, 0.9 is going to correspond to whatever this value is here on the Z distribution. Okay, and they are related through the conversion, right? Z is equal to X, or in this case, Y minus mu upon sigma, right? So we go from this distribution to that distribution through this link, which means that this value here is going to correspond to that value. So what we want to do is want to find the Z value that's got a probability of 0.68. So we're going to look at our table of data. And let's see if we can find 0.68. We want to get the closest thing that's just below. And that to me looks like that value there, right? Because if we go beyond that, we're going to be in 0.6808. That's too big. So we want 0.46. But then we want to get even closer. And I think that if we add 25 little digits at the end, we're going to end up with 0.6797. But if we add 29, we're going to end up with 0.6801. So that's closer, right? So we want to get as close as we can. So in other words, our value of Z is 0.468. Okay, 0.468. So let's just put that in. That Z value is equal to 0.468. Okay, so now we can say, well, Z is equal to Y minus mu upon sigma. We want to find sigma. So we can say that sigma is equal to Y minus mu upon Z. So we just put in our values, right? Our Y value is 0.9, 0.9. Our mu value is 0.75. And our Z value was the 0.468. 0.468. And if I key all of that in, then what value do I get? I get 0.321. 0.321. Okay, I'm just going to double check that against the mark scheme. 0.321. Yep, that is the right answer. Okay, then, here we are in question 3. Tim has 2 bags of marbles, A and B. Bag A contains different types, white, red, and yellow. Bag B also contains white, red, and yellow. Tim also has an ordinary fair 6-sided dice. He rolls the dice. If he obtains a 1 or a 2, he chooses 2 marbles at random from bag A without replacement. And if he chooses a 3, 4, 5, or 6, he chooses 2 marbles at random from bag B without replacement. Find the probability that both marbles are white. Well, okay, I think the best way to do this is to draw a probability tree, right? So the first thing that he does is he rolls his dice. And after he rolls his dice, he's going to choose one of 2 bags, okay? So he could either roll a 1 or a 2, in which case he's going to go for bag A, or he can choose a 3, 4, 5, or 6, in which case he's going to go for bag B. Now, of course, what's the probability that he chooses this track? Well, it's going to be 2 out of 6, which is the same as a third. And this guy, therefore, is going to be 2/3. Okay? All right, then. Well, let's say that he does choose bag A because he got a 1 or a 2. Then he can either get a white, a red, or a yellow. So we can draw those as outcomes there. So white. Let's do that again. White, a red, or a yellow. Okay, like that. White, red, yellow. But actually, we only really care about whether or not he gets 2 whites. So I'm not going to draw the full diagram. What I'll just draw is this other guy here. So he gets another white on the second pull. Okay. All right, 3, 4, 5, and 6 is basically going to be the same thing. He's going to choose from bag B. He could get a white, a red, or a yellow. We're only really interested in him getting 2 whites, so I'm going to draw like that. Okay, white there. Okay, now what was the probability in bag A of choosing a white? Well, there are 8 whites there, and there is a total of 12 marbles to choose from. So that probability is 8 upon 12. Okay, but sorry, not 12. Beg your pardon, 15, isn't it? Right? 8 plus 4 is 12, plus 3 is 15. So 8 upon 15 is the probability of getting a white. Now, if he chooses without replacement, then what does that mean? Means the probability of the second white is 7 out of 14. Why is it 7 out of 14? Well, because originally there were 8 whites in the bag, and he's taken one out, so there are only 7 whites left. And of course, originally there were 15 marbles in the bag, and now there are just going to be 14 because he's taken one. Okay, for bag B, there are 6 whites out of 6 plus 7 is 13 plus 2 is 15. Okay, so again, 15. So choosing the first white would be 6 out of 15. Out of 15, beg your pardon. And then better just rewrite that, I think. 15. And the next one will be 5 out of 14. And why will it be 5 out of 14? Well, because you selected one white, so you've got one fewer whites, so you got 5. And of course, you selected one marble, so you've got one fewer marble, so you got 14 instead of 15. Okay, then, well, what we can do is we can calculate the probability of each of these pathways. So this is going to be a third times by 8 fifteenths times by 7 14ths. Okay, and this guy here is going to be 2/3 times by 6 15ths times by 5 14ths. Okay, it's probably a good place for us to practice cancelling things. So I can cancel off by 7 there and get a 2. And I can cancel off by 8 there, can't I? So I divide top and bottom by 2, I get 4. So I get that is equal to 4 upon 45. And then this guy down here, so what's going to cancel off? Well, I can divide top and bottom by 5, can't I? So that would become 1. And that guy there would become 3. And I can divide top and bottom by 3. So that would become 2, and that cancels off. So anything else that cancels? Yeah, I can divide top and bottom by 2. So divide that by 2, that becomes 7. So what I'm left with is 2 on the top. Yep. And then 3 times by 7 on the bottom, which is 3 upon 21. So those are the 2 different ways I could get my answer. So what have I got to do? Well, I've got to add up these 2. So my end answer is going to be 4 upon 45 plus 2 upon 21 is equal to 58 upon 315, right? So that is the probability of getting two whites, okay? Okay, then part B of this probability question, find the probability that the 2 marbles come from bag B, given that one is white and one is red. Okay, the key word there is given, which means you've got conditional probability. And if you see me do these questions before, the way I do them is I make sure I define the 2 events very clearly. So I'm going to call the events X and Y. I'm not going to use A and B here because I don't want to confuse them with the 2 bags that are called A and B. So event X is that the 2 marbles, so the marbles come from bag B, right? So that's event X. And event Y is that we have got 1 white marble and 1 red marble. Okay, so we want to find the probability of event X, which is the 2 marbles come from bag B, given event Y, which is that 1 is white and 1 is red. And hopefully you can recognize that we're finding conditional probability, so we can use this formula. The probability of X given Y is equal to the probability of X intersection Y, so the probability of both X and Y happening together, divided through by the probability of y. So what do we need to do? Basically, we need to find this probability, right? The probability that the marbles come from bag B and one is white and one is red. And also we need to find the probability of y in general, which is the probability that one is white and one is red. Okay, so let's go up to our diagram. So I think what I'm going to do now is I'm going to amend this diagram. All right, so let's get rid of all that. Not interested in that anymore. What are we now interested in? We either want a white or a red here. Okay, so a white becomes white and a red, or we want a red and then a white, which is going to be that guy there. So we're interested in that particular pathway. And we're also interested in the same from bag B. So if we had a white, we'd be interested in getting a red. Okay, and if we had a red, we'd be interested in getting a white. Okay, so we want that guy. Okay, so I would suggest that you redraw your diagram, right? So don't rub it out because you want to get marks from it for part A. But what I'm going to do is I'm just going to amend it because it's a bit faster. Okay, now let's think about all these probabilities. So let's take this first pathway. So we got a white in the first one. Well, how many reds are there in bag A? Bag A has 4 reds. Okay, so firstly, this probability here of getting a red on the first round would be 4/15. And then what would this probability be here? Well, there are still 4 reds to choose from because we haven't taken one yet, but there are only 14 marbles in the bag now. So this is going to be 4 upon 14. And what would this probability here be of having a white? Better just change that. Of having a white. Well, we haven't selected a white yet, so there are still 8 whites remaining, but there are now 14 marbles in the bag, so that's going to be 4. It's going to be 8 upon 14. Okay, because we've got 8 whites out of a total of 14 marbles. Okay, well let's go down to this guy. So what for bag B? What was the chance of getting a red? There are 7 reds, aren't there, in bag B? So this probability here would have been 7/15. Well, basically the same thing we've got to consider. If we had a white in the first pick, then in the second pick, we've got 7 reds to choose from. And we've only got 14 marbles to choose them from. And for this guy, we're going to have 6 out of 14. Why? Because we've got 6 whites still, right? Still 6 whites, but we've only got 14 marbles there. All right, so now let's try to calculate all these probabilities. So we'll do the first pathway, which is this guy here. So if I calculate that guy, I'm going to get a third times by 8/15 times by 4/14. Okay. If I do the next pathway, if I do that guy, then what I'm going to get is a third times by 4/15 times by 8/14. Okay. Now, if I do this pathway, this guy there, then what I'll get is 2/3 times by 6/15 times by 7/14. And then the last pathway is 2/3 times by 7/15 times by 6/14. Okay. And I think I can go ahead and try to simplify all of these, and I'll try to simplify them by cancelling, I think, as much as I can. So I will divide top and bottom by 2, I think. So that will make that 2, and that will make that 7. Is there anything else I can do? I don't think there's much I can do there, actually. So maybe the best thing is for me to just sit down and calculate all these with my calculator. Let's just try the other one, see if I can simplify those. Nah, I don't think there's much that I can do here. So what I'll do is I'll calculate them all with a calculator. Okay, if I do all of that, so I add them all up, then what I get is that the probability of x intersection y, the probability of y, so the probability of getting one white and one red, so that is me adding up all of these guys, right? So if I add up all these, that's the probability of getting one white and one red. So let me just write that down here. so the probability of one white and one red, which is what I called event Y, then what I get is 116 upon 315. So that's 116 upon 315. Okay, so that's the first thing. Second thing is the probability of X intersection Y. Well, that means that the marbles have come from bag B, and also that they're one white and one red. So what does that refer to? That refers to having these two outcomes here, right? Because these are coming from bag B, okay? And they're also white and red. So we take those guys and we add those up. That's the probability of the intersection. So let's write that down. So the probability of the intersection of X and Y is the summation of those two probabilities. And if I do that, I get 4/15. Okay, so if I do that, I get 4/15. Okay, and therefore the probability of X intersection Y is going to be the probability of the union, the 4/15. Okay, so 4/15 divided by the probability of Y, which is 116 over 315. Okay, and if I put all of that into the calculator, what do I get? I get 168 upon 232, which is 21 upon 29. Okay, so my final answer there should be 21 upon 29. Okay, I hope that was helpful. I think the key thing to that is just defining your events nice and clearly so that you know what you're looking for. You're looking for the intersection of X and Y and the probability of Y. Okay, question 4. The weights X kilograms of 120 students in a sports college are recorded. The results are summarized in the following table. We want to draw a cumulative frequency graph to represent this information. Now, basically, the way we draw a cumulative frequency graph is the upper boundary of each of these classes is where we plot our cumulative frequency value, right? So, for example, here, we would plot the coordinates 65, 38. What does that kind of represent? It means that once we got to the upper boundary of this, once we got to 65 kilograms, we know that we've included at least 38 people. Okay, so we don't plot it in the middle of a class. We plot it on the upper edge of the class. Okay, so we just got to plot this. Our x coordinates need to go from 0 to 100, or we could actually cut it up. We go from 40 to 100. So if I start 40 here, for example, then that would be 50, 60, 70, 80, 90, 100. I think that makes sense. So if I was to draw that, there we go. That would be my x-axis. Okay, and I'm going to indicate a break there to say that I'm starting at 40, beg your pardon. So start at 40, then this would be 50, 60, 70, 80, 90, 100. Now I need to remember to include labels, right? Very common to lose marks for that. And you also need to include the units for the labels, otherwise you're going to lose marks for that. It's going to be incredibly annoying. And then the y-axis is going to be our cumulative frequency. So you can write CF for short, I think, but I'll just write cumulative frequency. So cumulative frequency. Okay. And that's got to go all the way up to 120, isn't it? So that'll be 20, 40, 60, 80, 100, 120. Okay. And then we just got to plot these points. So we've got to plot the point 40, 0, which is like that. And then we've got to plot the point 60, 14. So 60, 14 is like that. It's a bit hard for me to do it on the tablet, so I hope you can get it more accurate when you do it. 65, 38. So 65, 38 is like there. Yeah, that should be okay. And then 70, 60. So that should be like there. Okay, 70, 60. And then 85, 106. So 85, 106 is like there. And then lastly was 100 and 120, which is going to be like that. And what we try to do is we try to draw like a smooth curve that connects them. It's going to be a bit difficult for me to do this, guys, with a tablet, so I hope you'll forgive me, but I'll try to draw something like that. Something like that. Oh dear, it's not great. Let's try to get it a bit better. Okay, something like that. It's going to curl back in to be something like that. Okay, all right. So you can't do dot to dot. It needs to be sort of curling a little bit. Now let's just look at the mark scheme, see what they ask for. Okay, method mark at least 3 points plotted accurately at the upper class end points, a linear cumulative frequency scale and a linear weight scale. With at least 3 values identified on each axis, right? So you actually got to put 20, 40, 60, 80, 100, something like that. Next mark, all points plotted correctly. The curve is drawn within a tolerance level, right? So you can't go completely wacky. And joined to 40, 0. The axis must be labeled cumulative frequency weight and include the kilograms. And that's it. Okay, so that's how you're going to get your marks there. Just be nice and careful. Should hopefully be an easy couple of marks. Okay, then part B of this question. It is found that 35% of students weigh more than W kilograms. Use your graph to estimate the value of W. Well, if 35% of students weigh more, then that means that 65% of students weigh less. Okay, so we want to find that value of W where 65% of students are less than that. So we've got 120 students in total. And so we want to find out where the 65th percentile of them is. So we're going to multiply that by 65 upon 100. And if we do that, then what we're going to get is 78. Okay, so we get 78. So what we're interested in is the 78th student. So let's go up to our graph then. Let's find where 78 is. Okay, so it'll be roughly there. So let me try to draw this on. So it'll be kind of like that. It's not so great. And I go down, I'll read that off. And that to me looks like 74. Okay, so 74. Oh, sorry, beg your pardon. All right. And so I think my answer should be 74 or thereabouts. Let me just check the mark scheme, see what they go for. Okay, they go for 76 kilograms. It must be between 75 and 79. Okay, so my answer would have been technically wrong, but it would have been wrong because I've basically doing it on a screen. It's quite difficult to get it right. So if I'd have drawn it a little bit to the right and got 75, then I'd have been right. But yeah, I hope you understand that the method is basically correct. Okay, for part C, you want to calculate estimates for the mean and the standard deviation. Well, if we're going to calculate an estimate, basically what we need to do is we need to take each of these groups and divide it up and find the frequency that's in that group. So I'm going to draw out a new table. And if I draw out a new table, then what I need to do is I need to have the midpoint, firstly, of each category. So midpoint. Okay. And so the midpoint between 0 and 40 is going to be 20. And then I need the midpoint between 40 and 60, and that's going to be 50. And then I need the midpoint between 60 and 65, which is going to be 62.5. And I need the midpoint between 65 and 70, which is 67.5. Between 70 and 85, if I want to do that, just add them up, I think. So 70 plus 85, and then divide through by 2 is 77.5. And then 85 and 100, so 85 plus 100, and then divide by 2 is 92.5, right? So I've got these as my midpoints. Okay, so 92.5. And I need to find the corresponding frequency in each group. Well, in the first class, I've got 0. Okay, and then in the second class, between 40 and 60, I'm going to get 14. And then what about in the next class, in the third class? Well, remember this is a cumulative frequency, right? So this 38 includes not only the group of people between 60 and 65, but also includes the 14 who are below 60. So what I'm going to do is I've got to do 38 minus 14, and that's going to give me 24. Okay, so 24 in this group. Okay, and then in the next category, between 65 and 70, I do 60 minus 38, and that's going to give me 22. Next category, I've got to do 106 minus 60, which is 46. In the next category, I've got 120 minus 106, which is 100 and not 114, beg your pardon. It's just 14. Okay. Well, then if I want to find an estimate for the mean, right, the mean, or x bar, is sigma fx over sigma f, which is just the total number of people. In this case, is 120. Okay, what does sigma fx mean? It means I do this times this, plus 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 this times this. Okay, if I put it all into the calculator, I should get my answer. So let me just have a quick look at that. Do it on the calculator. So if I key that all into the calculator, then what I get in the end is I get 8545 over 120. Okay, so that's 8545 over 120. And then if I put that into the calculator, what I get is 71.2. Okay, 71.2. Okay, then what about the variance? So sigma squared, the estimate for the variance. Well, basically what we need to do is we need to find the sigma fx squared, okay, upon n upon 120, minus the mean, which was our 71.2. 71.2. All squared, right? So what we do is we basically find the mean of our x squared values, and then we subtract it off from the mean of the values squared, right? That's the definition of the variance there. Should be on your formula book. Essentially what we do is we take each of these values, we square them. So 20 squared, 50 squared, 62.5 squared, 67.5 squared, 77.5 squared, 92.5 squared. And then we take those square values and we multiply them by this. So it'd be 20 squared times by 0, plus 50 squared times by 14, plus 62.5 squared times by 24, plus 67.5 squared times by 22, plus this squared times by that, plus this squared times by that. Okay, so I'd have to key that all into a calculator, and I suggest you do it the long-handed way. But what I'm going to do is, if you don't mind, I'm just going to skip straight to the end. I'm going to get 138.23. Okay, 138.23. And if I was to square root that, because remember I want to get the standard deviation, what I get is 11.8. Okay, so in the end here, what I get is 11.8. Okay, as I say, I think that the key to that is really not doing the number crunching, right? So I did the number crunching fairly quickly because I don't want to make it too boring for you to watch me just wait to put numbers in a calculator. There's one thing you really need to know about this. Firstly is you need to know each class. So this is the class 0 to 40, this is class 40 to 60, 60 to 65, 65 to 70, 70 to 85, 85 to 100. That's the class. Then you need to find the midpoint of each of those classes, right? So you can add up the two extremes and divide by 2. And then you need to remember this isn't the cumulative frequency anymore. This is the frequency. So to find the frequency, we've got to take the two terms and find the difference between them, right? So 38 and 14, the difference is 24. 60 and 38, the difference is 22, and so on and so forth, right? And if you do that, then you're basically set up, and you just got to plug the numbers into the formula. But that thing there is the key step. Okay, question 5. The probability that a driver passes an advanced driving test is 0.3 on any given attempt. Deepak keeps taking the test until he passes. The random variable x denotes the number of attempts required for Deepak to pass the test. Find the probability that x is between 2 and 6 inclusive. Okay, well, to be honest, I think with all these questions, the best thing to do is just draw out a diagram so you can understand what's going on. So each time, Deepak's got two options, right? He either passes or he fails, okay? And the probability of passing each time is 3/10, and the probability of failing each time is 7/10, right? Now, if he passes, he's not going to repeat the test, is he? He's only going to repeat the test if he fails. So what we can do is we can carry on this diagram here. So could be a pass or a fail on the second attempt, a pass or a fail on the third attempt, a pass or a fail on the fourth attempt, pass or a fail on the fifth attempt, or a pass or a fail on the 6th attempt, and of course it's going to keep going and going and going. Now, what you could do is you want to find the probability that he passes between 2 and 6 times, right? So you can't have that. That's the probability he passes on the first time, but you could calculate that probability and then add it to that probability that's passing on the 3rd time. Then that probability, that's he passes on the 4th time. That probability, he passes on the 5th time. And that probability there, which he passes on the 6th time. So you could calculate all those probabilities and add them up. But what's a smarter thing to do? The smarter thing to do is to consider the two things that you can't have, right? And what you can't have is you can't have that guy, he passes on the first time, and you can't have this guy, which is he fails on the 6th time, right? Because if he fails on the 6th time, he's got to go again, and then he'll be passing on the 7th time or the 8th time, whatever, right? So what we're going to do is we're going to say the probability is equal to 1 minus this outcome, which is 3/10, okay, minus this outcome, which is 1, 2, 3, 4, 5, 6 consecutive fails, which is 7/10 to the power of 6. All right, so that's going to be the simpler way to get our answer. And if we key all of that into a calculator, then what we should get is 0.582. Okay, so 0.582. Okay, now as I said, I think diagrams with all these questions make everything a lot easier. Draw it out so you can see what it is you want and what it is you do not want. All right, then part 2 of this question, we want to find the expectation of x. Now, I think you just need to notice that this is only worth 1 mark, right? So if it's only worth 1 mark, it should be something fairly straightforward. And unfortunately, it just means you've got to refer to the formulas that are on your formula sheet, okay? So this is a geometric distribution, right? Because what we're testing is the number of attempts it takes until we get a success. That is a geometric distribution. And the expectation of a geometric distribution is given by 1 divided by the probability of success. Now, the proof for that is a little bit complex, and I think it's really beyond the scope of what we're doing here. So for the moment, you just have to accept it, which is really what I don't like. I don't like telling people to accept things, but maybe later on I can do another video showing why that is the case. But for the time being, all you got to know is you got to do 1 divided by 3/10, which is the same thing as 10 upon 3. Which is the same as 3 1/3 or 3.33 recurring. Okay, then part B of this question, 5 friends will each take their advanced driving test tomorrow. Find the probability that at least 3 of them will pass tomorrow. Now, this is a classic thing they like to do with these questions is they like to change the distribution midway through the question. So when we started in part A, we had a geometric distribution, which is basically the number of attempts that it takes until we have a success. This is a binomial distribution because what we've got is we can think of each of the friends as being one trial. So there are 5 trials here, and we've got 2 different outcomes, which is either pass or fail, success or fail. So what we're going to do is we're going to redefine our variable. So we're going to say let x be the number of friends who pass, and therefore x is binomially distributed 5 friends, each friend representing 1 trial, probability of success of 0.3. So if we want to find the probability that at least 3 of them pass, we find the probability that x is greater than or equal to 3, well, that's the same thing as finding the probability that x is equal to 3, plus the probability that x is equal to 4, plus the probability that x is equal to 5. And so we need to write out each of those probabilities. Well, if we've got 3 successes, we're going to get 0.3 to the power of 3. But then if we've got 3 successes, it also means we've got 2 failures. So we've got 0.7 to the power of 2. So we've got to do that times by that. And how many ways can we get that? Well, that would be 5c2. So each of these probabilities, right, it represents the probability of success to the power of however many successes we had. And then the probability of failure times by however many failures we have. And then multiplied by the number of ways in which we could have had that outcome, right? For example, we could have had success, 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 fail, fail, or success, fail, fail, success, success, and so on and so forth. So we just do it for all the others. We get here 5c, sorry, that should be 5c2 there, beg your pardon. 5c4, 0.3 to the power of 4 times by 0.7 to the power of 1. And here, this will be 5c5 times by 0.3 to the power of 5, and then 0.7 to the power of 0, because we've had no failures. So now what we're going to do is just got to key each of those values into the calculator, right? So if I key that in, I get 0.1323 and 0.02835 and 0.00243. So I suggest you just do each of those twice and just double check your answers. And if we add all those up, we get 0.163. Okay, so just be careful at the end. Make sure you key in everything correctly. I think do each of the three terms separately and then repeat it just to make sure, and then add them up and then repeat that again. Just want to be sure that you're catching all the marks, you're not losing any due to calculation error. Okay, then here we are in part C. 75 people will take their advanced driving tests next week. Use an approximation to find the probability that more than 20 of them will pass next week. Okay, well, let's define our variable, right? We're going to say let X be the number of people who pass. Okay, and if that's the case, then X is going to be binomially distributed 75, comma 0.3. Okay, because we can think of this as a binomial distribution where we've got 75 trials, because each person is like a trial, and the probability of success is 0.3. Now, what we're being asked to find here is being asked to find the probability that X is greater than 20, which is the same thing, by the way, as X is greater than or equal to 21. Now, this is going to be very boring to try to do manually, right? You've got to figure out the probability X is 21, 22, 23, 24, 25, all the way up to 75. So what instead we do is we use an approximation, and we approximate using the normal distribution. Now, if we do that, then the mean of the normal distribution is equal to n times by p, and the variance of the normal distribution is equal to n times by p times by q, where q is the probability of failure. So what we've got here is we've got to calculate 75 times by 0.3, and then for the variance, 75 times by 0.3 times by 0.7. So that's what I'm going to do. I'm going to calculate that. So 75 times by 0.3 is 22.5. Okay, and then times that by 0.7 is 15.75. Okay, 15.75. All right, that means that we can write the following. We can say that X is normally distributed with a mean of 22.5 and with a variance of 15.75. Okay, but I'm going to rewrite that as the square root of 15.75 squared because I want to remember when I come to use it later on. Now, what did I want to do? I wanted to find the probability that X is greater than or equal to 21. Now, before I do this, I need to remember that what I've done is I've moved from a discrete distribution to a continuous distribution. Okay, so if I do that, then I want you to imagine this, right? With a discrete distribution, here we've got whatever, 19, 20, 21. And a discrete distribution, we've got probabilities at these fixed integer values, like that, like that, like that, whatever it is. Okay? When we convert it to a continuous distribution, what we've done is we've kind of done that, right? So it's no longer probabilities at fixed integer values, but it's continuous. It spreads between 20 and 21, for example. So if I want to calculate the probability that X is greater than or equal to 21, it now includes basically this whole region here, right? So when we think about 21 now, we're not thinking about an integer. We're thinking about kind of a range of values that goes from 20.5 all the way up to 21.5. Okay, so if we want to calculate the probability that X is greater than 21, greater than or equal to 21 rather, then we need to actually include this part here using the continuity correction, right? So we are finding actually the probability that X is greater than or equal to 20.5, right? That's our continuity correction. All right, then let's try to do that. probability that x is greater than or equal to 20.5. We can convert to the z distribution. The probability that z is greater than or equal to 20.5 minus the mean, which was 22.5. And then all divided through by our standard deviation, our sigma, which was the square root of 15.75. The square root of 15.75. Okay. And I better key that into my calculator and find out what value of z that gives me. Let me go and find out what value of z that is. Okay. Okay, that gives me negative 0.504. So negative 0.504. Okay, and that creates a little bit of a problem for us because the z distribution, number one, it doesn't tell us values for negative z coordinates, and also it doesn't tell us the probability that we're greater than a certain value. It only tells us the probability that we are less than a value. So we need to draw a quick diagram to try to visualize what's going on here. So if I was to draw this out, okay, I want to find the probability that I am greater than negative 0.504. So here's negative 0.504. Okay. So I want to calculate the probability of me being to the right of that, right? So in other words, all of that region there, like that. Well, via symmetry, what I can say is, if I was to take positive 0.504, right, then the region that I've shaded in orange would be equal to the region that I'm about to shade in green, right? This whole region here, right? Those two things are the same. So what I can write is that the probability of being greater than negative 0.504 is the same thing as the probability of z being less than positive 0.504, okay? Well, then what I need to do is I need to read off that probability from my z value. Now, I've already done this in quite a few questions, so I hope you don't mind me just skipping ahead. And I get 0.693. Okay, so 0.693. If you want to see how I read the value off the table of data, you can go back to one of the previous questions where I used the tables. But that is how we get that answer there. Okay, question 6, a combinations permutation style question. Jay, I hope I'm pronouncing that right. Jay and his wife Kaz are having a party. Jay has invited 5 friends, and each friend will bring his wife. Okay, well, that sounds been married for 10 years. That sounds absolutely awful, I must say, but never mind. At the beginning of the party, the 12 people will stand in line for a photograph. How many different arrangements are there of the 12 people if Jay stands next to Kaz and each friend stands next to his own wife? Okay. Well, I think the best thing to do with all these questions is we just want to draw it out, right? So we've got 12 people. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And these are all going to be paired up, aren't they? So you got husband and a wife, husband and a wife, husband and a wife, like that, like that, like that, like that. Okay, so how many ways can we arrange these? Well, firstly, what you want to do is you want to consider each of the married couples as being one unit. So how many units have we got? We've got 1, 2, 3, 4, 5, 6. So how many ways can we rearrange 6 units? That's 6 factorial, or 6p6 is the same thing. And then for each one of those arrangements, each of these couples could be arranged in 2 different ways, right? So husband and wife, or wife and husband. So that'd be times by 2. But we've got it for all of these different cases, right? For each way of arranging this couple, there's another 2 ways of arranging that couple, and another 2 ways of arranging that couple, and another 2 ways, and another 2 ways, and another 2 ways. So we've got 2 times by 2 times by 2, 6 times. So that's 2 to the power of 6. So our answer should be 6 factorial times by 2 to the power of 6, which is 46080. Okay, that's that. Okay, part 2. How many different arrangements are there of the 12 people if Jay and Kai occupy the 2 middle positions in the line, with Jay's 5 friends on one side and the 5 wives of the friends on the other side? Now, I think you need to be very careful when you read this, because I got it wrong when I first read it. So we're going to do it very carefully. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And J and Chi are going to be in the middle. So that's J and Chi, right? But of course, it could be the other way around. You could have Chi and J. And the other thing you need to think about is, so you've got J's 5 friends on one side and the 5 wives on the other side. Now, it doesn't specify that the male friends, right, the men are on this side, and the women are on this side, right? So that's what I assumed when I first read the question, that the men are going to be on the side with J in it, and the women are going to be on the side with Kaz on it. But that's not actually true, right? It could also be the case that the women are on that side next to J, and the men are on this side next to K, because it doesn't specify. It just says J's 5 friends on one side, right, and the 5 wives on the other side. Okay, so what we got to do is we got to think about each of this. Now, how many ways could we rearrange the 5 men on this side? That'd be 5 factorial. How many ways could we rearrange the women on this side? That would be 5 factorial. Well, then we just got to think about how many other different ways we've got. Well, the first thing we could do is we could keep J and Kaz here, and then switch the men and the women. So that's going to represent a second identical alternative. So just to write that, we've got 5 factorial times by 5 factorial times by 2, right? If we switch the men and the women. And then we could do exactly the same thing if we switched J and Kaz, right? Then we're also going to have we're going to have a repeat, right? Because if I was to switch J and Kaz like that, so make that Kaz and J, then I could have the men on one side, the women on the other, and then switch again, women on one side and the men on the other. So what we end up with is 5 factorial different ways of arranging the men, times by 5 factorial ways of arranging the women, times by 2 if I switched the men and the women, and then times by 2 if I switched Kaz and J. Okay, Kaz and J, right? Everyone knows a Kaz and J in their friendship circle, I'm sure. And sorry if you are named Kaz or Jay out there in the world, and I've just insulted you unwittingly. I'm very, very sorry. It just seems to me that some of the names that they choose can be a little bit strange, but maybe perhaps I've lived a very insular and sheltered life. That may be the case. All right, now what does that all multiply out to? Oh dear. Right. 57,600. Okay, 57,600. Isn't that exciting? That's the number of different ways in which we could have a bland photo that will eventually be forgotten. Okay, bye-bye. Okay, so part B of our combinations permutation style question. For a competition during the party, the 12 people are divided at random into a group of 5, a group of 4, and a group of 3. Find the probability that J and Kaz are in the same group as each other. Okay, well, basically here what we've got is we've got 3 different situations to consider where J and Kaz are either in the group of 5 or in the group of 4 or in the group of 3. So I think what I'll do is I'll draw a quick table. All right, so this will be the group of 5, the group of 4, and the group of 3. And we've got 3 different situations to consider. So let's take the first situation where J and Kaz are in the group of 5. Okay, well, if that's the case, then the group of 5 has already got 2 people in it. So we need to choose 3 people. Where are we choosing them from? Well, we're choosing them not from a group of 12, but from a group of 10, because J and Kaz are already included. So this is going to be 10C3, right? Because I'm choosing 3 people out of 10. Why are we using combinations, by the way, and not permutations? Because in this question, order is not important. We're just selecting people. We're not selecting them with any particular arrangement, okay? All right, then, having chosen the group 5, we now want to choose the group of 4. So how many people have we got left? Well, we had 12 people. We've chosen a group of 5. So there are 7 people left remaining. So that's going to be 7C4. And of course, at the end, we're going to have 3 people remaining. We're going to choose 3 of them. That's 3C3. But of course, 3C3 is just equal to 1. Okay, then. Let's say that J and Kaz are in the group of 4. If that's the case, then we need to select 2 other people for the group of 4. And we've got 10 people to choose from, so that would be 10C2. And of course, once that's happened, we need to select the other two groups. So let's say we chose group 5. Well, how many people have we got left? We've got 8 people left. We want to choose 5. So that would be 8C5. And then we've got 3 people remaining. So again, that would be 3C3. Okay. Okay, lastly, what if J and Kaz are in the group of 3? Well, that means that we've only got one person left to choose from in that group of 3, and we're choosing from 10 people. So that would be 10C1. Okay. And then what we've got to do is we've got to choose the remaining 2 groups here. And if I've already chosen a group of 3, that means that I've got 9 people left remaining. And I need to choose 5 of them. So that's going to be 9C5. And of course, if I've chosen 5 out of 9, I've got 4 people left remaining, and that would be 4C4 there. But again, 4C4 is just equal to 1. Now, for each of these guys, what I've got to do is I've got to multiply them together. Okay, so I'm going to multiply like that. Okay, and then having multiplied all these, I'm going to get 3 different values for each of the cases. And then having done that, what have I got to do? I've got to add up all of these values. Now, why do I add up? Because I've got 3 different cases, right? Either J and Kaz are in the group of 5, or they're in the group of 4, or they're in the group of 3. Okay, so therefore we are going to add up all of those cases. Okay, then if I do that, then I get 4,200, I think, for this one, 4200. And if I do the next one, I get 2520. And then if I do this one, I get 1260. Okay, so then what I've got to do is I've got to add these all up. If I add them all up, I get 7980. Okay, so 7980. Now, the question didn't ask me for the number of different ways it could be done. It asked me for the probability. So I need to consider the number of ways in which there are no restrictions. So if there are no restrictions, then what I need to do is I need to fill the group of 5. So the ways that I could do that would be 12C5. After I've done that, I need to fill the group of 4. So that would be 7C4. And after I do that, I need to fill the group of 3. Multiply, which would be 3C3. Okay, and if I multiply that all out, I get 27,720. And so therefore the probability is going to be the 7980 divided by the 27,720, and that is equal to 19 upon 66. And so 19 upon 66 should be my final answer.